Welcome to the Blue Screen Brothers podcast on YouTube. So we have already had an episode covering Defender for APIs, and now we're gonna sort of, talk a bit about things happening a bit more early in the release cycle through like CI/CD and things like that. And we have a lot of the same guys with us in this episode, so we're not going to take a round on everyone here. But we have Isabelle Mauny with us. Do you want to introduce yourself and just, show us some cool stuff?
Right. Thanks, Marius, and thanks, everyone. So yes, I'm Isabelle. I'm the field CTO and one of the founders of 42Crunch. And thank you for welcoming us on this podcast. And for the next 20 minutes or so, just explain a bit what is this shift left? Why do we have to do this? And a little demo of our capabilities and introducing the integration into the Defender Azure infrastructure and how this works. And then I'll let Marius showing you that into Azure Cloud. So without further ado, let me just go and actually share my screen. And here we go. You should see my screen now. And we'll get started, talking about customers. So we have a number of customers who have been using our products we're about 5 years old, 42Crunch ourselves. And, really what is true, has been true for the past years, is the realization that customers came through that API security is really a universal problem. We have customers all around different verticals. It can be fintechs, it can be IoT, it can be insurance, it can be, cars, connected cars and automation, all kind of problems. So because APIs are simply there, as it was introduced, I think, in the previous episode, to connect absolutely everything in this world, right? So what are our customers saying about APIs, right? And API security in particular? Well, the first thing they come to the realization is to say, well, our problem is we've been building security into our data centers to protect ourselves from attacks, right? At a time where we were supporting traditional applications, and bear with me with that picture for a second. Thinking that beautiful city here next to the water is actually your data center you're trying to protect. Right. And pretty much what we've been doing in the past years is building walls around our data centers, right? Firewall, network firewalls, application firewalls, but basically walls and series of walls, so that if a first wall would be falling down, which was why those cities in the ancient times, how they were protected, if one wall was to fall, then there will be a second one and a third one, and it will be water and boiling oils, and that will be poured on you, to make sure you actually don't get into the center. And there will be one kind of main entry point into the system, which is like, you can refer to that picture on that main door, which is right there in the middle, right? And you would have all those protection around it. Now, if you talk about APIs, I'm sure you all know where that is. This is Paris, of course. If you talk about APIs, what do we do every time we open an API? Every time we create an API, every time a developer creates an API somewhere, it's because they want to expose data or processes to outside of that data center, right? So if our data center now is this beautiful Arc de Triomphe in Paris, right? Every time we create an API, it's like we create a new avenue into this. So you see, protecting now at the edge and the traditional security measures are really not working well here, because it's not about making sure we build a wall and nobody can get in. On the contrary, what we're doing is every time we create an API, we punch a hole in that wall, right? And now what we have to do is we have to protect and control the flow of data and the flow of information going through those holes that we've punched a bit of everywhere. And that's really the challenge that CISOs are confronted to right now with API security, is they have to change the paradigm on how to do security, right? Now, what else is critical here? Well, the first other thing is, bear with me a picture again. This is actually a phrase I borrowed from a CISO I talked to maybe a couple years ago, who told us, APIs, I feel like there are mushrooms popping up all over my data centers, right? And the reason he was saying that is because it's actually extremely easy for developers to create APIs today. And again, APIs are what we're going to use to connect to absolutely everything, including outside of our data centers, right? Like we connect to, long are the days where people had everything in the house. On the contrary, like I have Azure Cloud, and there you have all your services are there. And if I want to go and integrate with services from Azure Cloud, what am I going to do? I'm going to use Azure CLI and APIs, right? So it's not only about the APIs that we create ourselves, it's about all those things around us that we need to go to and reach and consume data from through APIs. So it's really that this is like the heart of everything any modern or current company is doing, is having to control internal, external, third-party APIs across their data centers. And what makes it complicated, really, for AppSec people is that we've really given the ways for developers to be extremely efficient, extremely fast at creating APIs or integrating with APIs. You can do this graphically through many different tools. You can point to a database and get an API created for you. It is very easy to do. So developers are extremely efficient, extremely fast. And in that world, application security is really playing catch up, right? And there goes my first kind of message, and one of the reasons we created this company is how do we equip security people with ways that they can really be much more efficient at finding problems in APIs way earlier than they are today, and also in an automated way. Back to what I just said on the previous slide about my mushrooms, right? If I have 3 APIs popping up every day, anything which is manual is going to be problematic, right? And so the whole CI/CD integration that I'm going to show you now in the demo is really key, so that as APIs are being developed, we catch those problems and we can relate them
before it's in production, right? So
exactly, that's the whole point. So we actually very good segue into my next slide. Indeed, what is happening today? What our customers say today? They say, well, we have all those APIs popping up. We're trying to catch problems as early as possible, but there are so many of them, and there is so few of us. So that's another problem, right? In the average company today, you have something like 100 developers from one AppSec guy, right? And that's when you're lucky. That's actually a very generous number, right?
yeah.
So obviously that poor person alone cannot just keep up with 100 people creating APIs. That's just not going to work, right? So what they do, well, they concentrate on what is most critical. Like many times what our customers say, okay, let's start with the external APIs, the one that we expose to the outside world, because this is where the top risk is, which is true, right? It doesn't mean the internal risk is zero, but obviously the risk of exposing to the outside is higher than exposing internally in general, right? So let's start with those. And maybe this is like, whatever, 10% of all the APIs we have. It's still a lot, but let's focus on those. But in many cases, they tell us, we just crossing fingers. We have released this thing because business was pressuring us to do so. And, we hope that no one is going to find the problems before we actually can fix them or discover the problems, right? So that will automation start way earlier, finding issues way before they're actually we actually get into the final stages of the API lifecycle is really what we're about, right? It's about giving to developers, giving to AppSec people the tools that they need so that they ingrain really security along the API lifecycle. And that makes sense. Does that make sense? A question on it?
Yeah? Absolutely. And also it's not too uncommon that a so-called internal API suddenly is not all that internal anymore. There's new use cases where either single endpoints or certain parts of an API or something is suddenly external.
And that's actually, I have a good friend of mine used to give presentations around this, saying, you know, the typical story of, oh, we have a team, they create an API, it's only for themselves to help them being more productive. Then another team sees it and says, oh, this is a cool thing, can we reuse it? Right? And then, oh, we know we could expose that to partners. That would be really cool. They could really use that. And before you know it, this thing that was designed and secured for a very different use case and risk ends up being exposed to third party without really reevaluating the risk around it, right?
Exactly.
And so that's a very key point in what you're saying, is we have to make sure as an API evolves, we reevaluate the risk associated to it and take the appropriate measures as we do, right? So so then what happened? Right, so we have plenty of problems around APIs. I'm sure you guys have heard about OWASP Top 10, very famous, you know, the top list of problems that we have around, again, applications in general. This is a very well-established list of, which is really built from taking the real issues that happen in the real world and then, you know, kind of classifying them according to how often they happen, and how critical the problem is, and how exploitable it is, so how easy it is to exploit that problem. And that's how a top 10 is being created. And about 3-4 years ago, the talk was to, at the end of the traditional OWASP top 10 for applications, to put an API 10 like you have here, saying APIs are dangerous, right? Pretty much. But like as a top 10, at the end of the top 10 for all applications. And then people said, no, that makes no sense because APIs are different. Also, it's like they deserve much more than just a line at the end of the regular top 10. We actually need a separate top 10 just for APIs. And so this happened at the end of 2019. There's been a new version, early 2023. And just to illustrate some of those problems, but there's basically 3 categories around APIs. Is the control of data, control of like the data coming in and out. We'll talk about this in a second. The control of course, authentication, and in general, authorization, right? So let me just give you one example to illustrate something that happened. So this is a, just not offend anyone that didn't put the name. This is a very important, like we're talking 40 plus million entries, resources, users, actually, profiles that have been stolen about 3-4 years ago now. But it's very typical of the type of problems that APIs have, right? And so what happened here? There is this telco as an API, like this get that I've put here in the middle, which basically allows you, let's say they have a mobile app, it allows you to get your user profile with your phone number, right? So this 1888 blah, blah, blah is actually a US phone number, let's say. So what's the problem? Well, the problem number 1 is this ID, which in this case is a phone number, is guessable. I think there is a well-known format for a phone number. I can fabricate phone numbers very easily. I can create those. Or it could be because this is something I can guess because it's 123, and I can guess there's probably 124. In this case, it's a phone number, right? So a hacker can create a little engine that just generates random phone numbers, okay? That's the first thing. So what happens here is, that's what they do. They fabricate phone numbers. They call this endpoint, right? And problem number 1 is, of course, if I call this API and I'm Isabelle, right? And I call this from my web app with my token and my authentication, and I put my phone number, of course, that's all good, right? But now if I put Marius' phone number, then that's a difference. I should not be able to do that, right? Right? Because it's not my resource. And this is the number 1 problem with APIs today, is how to do authorization at the resource level, which in this case is a phone number, right? So I should not be able to access the profile of a user which is attached to a phone number unless, of course, that phone number belongs to me. And that's what they're missing here. They're missing that validation. So if a hacker goes and replaces a phone number by a different one that they don't own at all, then if they hit an existing phone number, they will get the user profile. And it was really there's actually another problem attached to this, which is it was leaking the return, like the data returned by that call was too much in terms of what it was returning, like the social security number and all those very critical pieces of data that really should not leak, through an API. So no control over the data. And to make this worse, and we can see why, there's no rate limiting, which means that hacker has been able to put multiple engines in parallel or all, going through that API call. And that's how they evaded like 40 plus million records until they were stopped in their tracks, right? And they did it over quite a long period of time. It's not like they've been, doing 10,000 requests per second, so they wouldn't kind of go under the radar a bit. But still, this should have been found, right? So just to say that this is really a problem. It's not about injections. It's not about the traditional application security type of issues. It's really about making sure that you have access to this data. Is it yours? Is it not yours? Is the API returning more data than it should? Are you going to control how many times I can actually do this? All of that is like the top three, right? That bridge here is kind of a summary of the top 3 of the top 10, and that makes sense, right? Any questions on this?
No, absolutely. And I've seen this exact very similar issue, but it was 15 years ago. It was a Norwegian telco where essentially when you sign up for a phone number, essentially you had to insert your social security number. Mm-hmm. And on the sort of backside of the front end, there was some kind of hidden API where the only input was the social security number. And in Norway, that is just based on your date of birth and then 3 numbers and 2 checksum numbers. Yep. Fairly easy to iterate over. I just, and PHP was the only thing I knew back then. So I just wrote a few, for loops in PHP, and essentially were able to extract several thousand numbers very quickly with full names and addresses.
Yeah.
So and that was just sort of a proof of concept. So it happens, and it's something that really should be discovered early, right?
So here you're going to hear about this. Maybe 15 years ago, you would have heard this about as IDOR in direct reference, right? Mm-hmm. Now this has been in API world has been renamed as BOLA, but same effects as exactly what you're saying. The difference I would say between 15 years ago and now is that because this API type architecture is like everywhere now, maybe that use case that was kind of isolated 15 years ago is now the mainstream way of writing applications. And that's why this is so, critical today in fact, right? So the question is, what are we going to do about this, right? So how am I going to know that indeed my API is leaking some data? How am I going to know that if I'm swapping user A for user B on a call, indeed it still goes through when it should be stopped? How do we test all this in an automated, scalable way across, again, hundreds of APIs, right? Our goal here at 42Crunch is to help you shift left. What does that mean? Right? You've heard this before, I'm sure. So shift left is really about how do we equip developers with new tools? And I'm insisting on this because this is very critical, right? Shift left is not about taking the tools we've used all our lives as security people and putting them in the hands of the developers. that is not going to work because those tools have not been built for developers. They've been built for AppSec people for very specific use cases, and using them, just taking them and just, you know, I have a colleague of mine some months ago, you know, a year ago maybe, who said this is not about shove left, it's about shift left. So it's not about taking everything we do in security and just shoving into the, you know, and getting the developers to use it. It's really about helping the developers become better at security. That's really what this is all about, right? So improve security because we're going to help the developers finding this stuff. As always say, developers don't want to introduce security problems, right? Simply because, well, it's going to come back right in their face. Nobody else is going to fix those issues but them. And if those issues are found very late in the life cycle, as we were saying before, the cost to actually fix those problems is going to be much higher than if they find this as they design or as they're developing the APIs. And that's what really the importance of shift left is actually improving, obviously, the security, but also being more efficient at finding and fixing all those different issues. That's really what the goal is, right? So the goal of 42Crunch at the high level, and I'm going to get into the demo now, is really to integrate our tools along the API lifecycle so that as soon as you start as a developer designing your API, you can start using our tools to, okay, if I'm testing this API now, what problems can I find interactively from my IDE, which I'm going to demo to you now, right? Can I now test my code against my code, send all kind of, you know, bad requests to my API and see how resilient it is, how good it is at handling those calls which are getting malicious, you know, type of inputs, but also automating those BOLA type testing, BFLA, which is just making sure, BFLA is about making sure that if there is an API, an endpoint which requires an admin role, right? What happens if I'm calling this with a non-admin role? It should be rejected, right? So that's another part of authorization of the API. So as a developer, I can do all that testing inside my IDE. Then I'm going to take that code, I'm going to push it into a typical CI/CD environment. Today, it's going to be GitHub Actions in the demo. And then the same tools are going to run inside CI/CD, but now with a compliance end goal. Because, okay, so we want to help the developers, and that's all fantastic, and we want them to be better at security and make it as easy as possible for them to find all those issues. But then what does security want? Security wants control. Security wants compliance. Security wants to establish rules by which it says, listen, if we find this problem inside those APIs, this is the bar to pass. You know, if we have found problem A, B, and C, well, maybe C is like just right now, it's not acceptable. A and B, we can tolerate maybe, but C, we can't. So we're going to go through CI/CD, then sorry, you know, you have a C in there, can't do, right? We're going to block the build, but we're going to do it at the beginning where it's easy for you to say, right, I know, I have to fix the C, it cannot go further, but we found it much earlier than what we would have done normally if we didn't do that testing in a continuous fashion, right? That makes sense?
Yeah.
Yeah,
absolutely.
So you do sort of both static and dynamic testing. You know, what people might know as SAST and DAST.
In spirit, if you want to relate it to something which is known, yes. The difference is, in our case, we don't look at the code. We're looking at the definition of the API. So, but let me show that to you right now in action, so it will be much clearer. So let me just get out of the presentation. Awesome. Okay, I'm going to open Visual Studio Code. Can you read this okay, or should I zoom a bit? Is it okay this way?
This is fine.
Okay, wonderful. All right, so what I have here, so we are in Visual Studio Code, in which we have installed, and by the way, anyone here listening can do this. You just go and search for 42Crunch or Open API. You're going to find a plugin, right, which is actually pretty successful on VS Code. That allows people to, developers to come and test those tools. So what is Open API? it's really, think of this as the contract of the API. It's a definition that says, hey, this is my API, that's what it does. So if we look at this for our open weather, for example, I was here looking at open weather, right? So in open weather, we have a get, we have some parameters, and then we have a response. So something to describe, hey, this is my API, that's what it does. This is data you need to bring in. This is data you need to bring that will come out. So we have a clear definition of between the producers and the consumers of the API of, hey, this is where we agree on. That's what our API does, right? So already in there, you have a lot of information on what the API is doing, on the data it's manipulating, right? And the first thing we're going to do, and we allow users to do, is to do something we call an audit. So, and this is really a static analysis in this case, if you want, except we're not really looking at the code, but instead we're looking at that definition, right? And so, for example, here it says, hey, you're using an API key. Are you sure? And this is also going into a query. So this is like in the URL. That's really bad. You don't want to do that, right? And because then every single time you save that URL, that API key is there in clear. That's a really bad idea. That, you know, but from open weather, that's the way it is. And then, hey, how's your data defined? Do we have security? Do we not have security? Or here, well, we have some data in. Let me take this guy. All right. So we have some data in, like that schema, right? And that schema says, I need a string. What? Okay, well, a string can be a lot of things. It can be a credit card number, it can be a name of a city, but you know, you need to tell me a little bit more, right? So we're going to help people to define the constraints around their API. What is the security that you have? What is the actual, what is the actual information you are transporting inbound and outbound, and helping the developers refine that data, right? And for every single issue that you have in here, you will have a description, an example, how this can be exploited, and how do you remediate it, right? So this is kind of the user, the developer view. The idea is they're here in VS Code, they click on audit, they get all this detail. This is a simple definition, it has only one operation. But if you had multiple operations, you could also do this audit operation by operation. As I am working on a specific endpoint, then I can just audit this little part and make it better and better. All right, I can do this straight here from my IDE. Wonderful. Now, we get all this information. Now, the same tool, the same audit is also available inside GitHub Actions. Okay, so here I have the same project, which is this API security tutorial. And inside my API security tutorial, if I go to Actions, I have an action which exists in here called Audit. What is that doing? So let me just run this live. So we'll see we have the same results as before. So what is this doing? This is really doing exactly the same thing we did when we clicked on that button, right? But on top of that, it's going to apply those compliance rules, right? Do you pass the bar or do you not pass the bar in terms of what the company actually requires, right? So there'll be no surprise here for the developers because they know, hey, you know, I had this result in my IDE. There'll be exactly the same results when it runs in CI/CD. There'll be no difference between the two, okay? So the same audit which is running here, let me just go and check this guy. It's doing the same audit, all right, and uploading the reports so I can see them, right? And so we see our open weather, which is here, right, as exactly the same score of 18 here at 71. Didn't get no, but it's exactly the same data with the same issues that have been found, but from within CI/CD. And by the way, this is a freemium action that you can take and use. You have a number of, see, I have 18 out of 25. So you have a full featured audit if people want to try here, that they can install that GitHub Action freemium, and it will work out of the box directly into their repos for a number of things, full feature thing. And the same is true. So now I have like defined my contract. This is what my API does. It's been refined. I have constraints. Okay, wonderful. Now the next step And actually, this step of the definition, same thing. I'm going to run this live over here. So this definition which has been created is really something that establishes this interaction between the consumer and the producer of the API. And maybe the API doesn't exist yet. Like we haven't written any code yet. So this really like shift left, right? It's like completely on the left. We're at design time. It will still be working and giving me some useful feedback, right? But then, of course, I'm going to start implementing this. So I don't know if you heard about this. There's this big movement in the API world called API design first, where indeed we start with the definition, with the contract, so that then whoever needs to consume can do so because they can mock, for example, an API, and whoever wants to, has to implement can take that same contract and implement the contract. So we can work in parallel, do the testing from that, etc. So as little as design and I have defined this, we can already start having some information. Now the scan part of the solution, now it says, okay, this is what you told me the API does. But now what we're going to do is we're going to give me an endpoint, give me a place to go, give me the contract. And what I'll do is I'll just invoke that API and send it all kind of bad data and see how resilient it is, right? And that's what the scan is doing. So this sample project I have here, which by the way, you can fork and use, will start an API, will go and scan it for vulnerabilities and get a report, right? Now, where do I see that report? Well, by default in here, what we do, and that's the segue into what Aris is going to show you now, we take those results from the execution of those two tools and we push them into code scanning, right? So we convert our reports into a serif format and then take that and push it so that now you can, see that same thing we were seeing inside VS Code, but you can see it here within the GitHub code scanning interface, right? And you can see that the data has been appearing here, and you can see exactly the same problem you see them there inside code scanning, right? So now we can have alerts on this. If we do this multiple times, because we have a fingerprint, it's going to be tracked. So we can see that people's, some problems disappeared, came back, the traditional, scanning type functionality. And I would end the demo part for me, unless you want me to show you something specific. That make sense?
Makes a lot of sense. No, this was really cool. So how? Let's say I have a few things that are sort of, well, I get it. So here there's 162 open things.
Yeah.
If I add something to my API and it is sort of by intention, it might be sort of bad. For example, I have an array that is infinite or something.
Yeah.
Because I have this dismiss alert and everything. Will it sort of reappear, or can the next time it's run, or can I sort of postpone it for 6 months, or is that sort of Defender for Cloud things?
So in the pure code scanning environment, you can indeed dismiss it and it will not appear anymore. Okay, it will still be tracked, but it will not appear as a problem anymore.
Yeah, won't fix, I guess. So,
yeah, exactly. Say no, I don't care about this one, because every single problem is specific to, because it has that fingerprint. We know exactly if the problem reappears and it's exactly the same one, so we can discard it.
Exactly.
Okay? Yeah. I'm not sure about Defender for Cloud if we do anything about taking that data and surface it into Defender for Cloud is what we're doing. And I know what I'm sure Aris can talk to the capabilities of filtering at that level.
Yeah, absolutely. No, this was really cool. So, Harris, would you like to show how, and I'm talking while my display driver is crashing. So if you, Harris, would like to show how things look in Defender for Cloud.
Yeah, definitely. Are you able to see my screen right now?
ask someone with a working display.
Yes.
Okay, perfect. Sounds good. So yeah, I'll just quickly walk through that as well. So thanks, Isabelle, for that demo. So next what I'll showcase is basically how these results now integrate into Defender for Cloud as well. So in the last episode, we talked a lot about Defender for APIs, runtime API security capabilities, but now this will show how we can actually bring shift-left API security testing capabilities and results into Defender for Cloud. So now that central security team has kind of visibility both in runtime security as well as in shift-left security as well. So quickly, what I'll showcase here is we have a demo repo here. This is also running that same 42Crunch audit workflow that Isabelle was showcasing earlier. And in this case, this ran and had some security results that came back that are available here within the code scanning tab, like what you can see here. So I already have a repository connected to my Defender for Cloud, and that's pretty much all I need. So all I need to do is environment settings, basically connect a GitHub repository to Defender for Cloud and set up this 42Crunch workflow in my connected kind of GitHub repo. That's all you need to do for the initial setup. And then those results will automatically show up within Defender for Cloud as well. This doesn't require you to actually enable Defender for APIs either. It just requires you to create that connector between Defender for Cloud and GitHub. So what I'll do now is I'll navigate to our recommendations tab within Defender for Cloud. And here I can actually just search for API security testing. And you can see we have this new recommendation that appears up. GitHub repository should have API security testing findings resolved. And I can actually go into this particular recommendation and see all of those same findings that we were seeing within that GitHub code scanning tab showcased within Defender for Cloud as well. So now as a central security team, I can see if somebody's pushing any insecure code into production, for example, and I can see what specific security checks were found. So for example, string schema and a request has no pattern defined. I can see here that this was called from that 42Crunch REST API static security testing tool, and I can see which repository was actually responsible for this finding here as well. So that's what's available within Defender for Cloud. And then you also have steps, of course, to go in and kind of remediate, and you can see what are all of your affected repositories in this case as well. And this also actually integrates with our Cloud Security Explorer as well. So say, for example, I need to prioritize my repositories based on their risk. This is an easy way to do that as well. So what we'll do is we'll just go ahead and create a sample query here. So let me just go here to code repositories. And let's say I'm only interested in security findings from public repositories. I'm not interested in private repos, but mainly just public repositories. I want to see which ones of those have any security findings. So for example, I can go in here and actually filter by that recommendation. So I can say, show me my code repositories that have that recommendation with that specific title. GitHub repository should have API security testing findings resolved. And let's say in this case that particular recommendation is actually unhealthy. So that means somebody is pushing something insecure to that repository. I can go and hit search here. In this case, let me remove this. And in this case, you can see, for example, we have all these repositories that come back that have that particular recommendation and their public repositories as well. So that's a really cool new insight. And again, this is just one recommendation. If you wanted to also see which of those have secret findings and other types of recommendations in parallel, that's an easy to craft query here as well. So that's the scope of the integration that we have today with the Defender for Cloud and 42Crunch. That's available right now actually in GitHub for public preview, and then support for Azure DevOps should come soon here as well.
Awesome. Thank you so much.
Is there any licensing information available yet, so you know under what license will this fall?
Yeah, that's a great question. So at least on the Defender for Cloud side, it is fairly free. Like connecting your repositories, either GitHub or Azure DevOps repositories, is free to do within Defender for Cloud. The Cloud Security Explorer and Attack Path feature set is a premium feature that requires DCSPM, the Defender for CSPM feature set, to get those feature sets enabled. For 42Crunch, this is a separate purchase. So what Isabelle was basically walking through is they have both the freemium and premium tier for 42Crunch. So if you want to go and get started today for free, they have that option, limited by number of scans, of course, to go and get kickstarted with that. And then they also have an offering available on the Azure Marketplace for you to go and purchase a more premium tier of 42Crunch as well.
Perfect, thanks.
So it doesn't require you to have a Defender for DevOps, for enabled.
Yeah, it's a great question. So Defender for DevOps is it's a more deprecated SKU that we have now. It's kind of just integrated within Defender for Cloud. We no longer have any like a specific plan that you need to enable for Defender for DevOps. And rather, you just have to go in Defender for Cloud and connect that repository for free.
Awesome. And do you only integrate with GitHub, or do you also integrate with, I don't know, GitLab, Defender, or DevOps, Azure DevOps?
Yeah, so today the public preview is only available for GitHub, but I will mention that Azure DevOps support will come fairly soon as well with this integration with 42Crunch.
Awesome. A lot of exciting stuff happening here in this space, and I have a lot of customers that are doing a really poor job at testing their APIs. So especially from the security side. So
especially like that you can start in Visual Studio Code and get to know it before you implement it. So it's easy to get started with it. So it's something you should just start to play around with.
Absolutely. And the fact that we are in VS Code makes it so much easier for the developers to accept it as well, because again, if you try to get developers outside of their development flow, it's always problematic. They want to be efficient and stay right in there. So that's been a very strong focus of ours.
Yeah, I think that's a really important thing here.
Yeah, I know. I completely agree. I see the same thing when we have other DevSecOps journeys. It's people, they tend to like their IDEs quite a lot. But could you maybe explain or give some insights to some of the emerging trends and that you see around API security right now? I think it could be relevant for our audience, especially now that you are so deep within it.
Yes, I'm deep into it. Trends. Well, definitely shift left is a trend. I think what has been happening in the past 3-4 years is that indeed customers have been realizing they needed something like Defender for APIs to know, what's my status, where am I, what do I have, which APIs do I have, because again, probably the development side of the house would know it, but the security side of the house doesn't, right? Because they're using completely different tools. Again, we're talking API management versus something else. So that visibility is not there. So surfacing that information has been extremely critical, and it continues to be critical. But again, and that's why I'm so happy about the work we're doing with Microsoft. It cannot go without, okay, well, I know all of this. I have that visibility now. What do we do about it? So now we know we have problems. Maybe we're leaking data. Wonderful. So that whole flow of, okay, now we have to take care about doing something about it. And it's the whole shift left part of this. So there's definitely a shift without playing with words. There's definitely a shift in 2023, 2024 into getting to, okay, now that's what we have to concentrate on. That's for sure. Of course, I think we're only at the beginning to understand what, GPT, AI, Copilot, all this great stuff are going to do for us. And actually both on the attack and on the defending side, right? So you start to seeing a lot of blogs and things about how to attack APIs with AI, and then the same thing the other way around. So we're probably only at the beginning of all this, and how to leverage things like GitHub Copilot, for example, to do remediation, to find those problems faster. Like us, we're looking at it on how to resolve the problems faster. How do we help? Okay, we're going to tell developers you have a problem there. How do we help them resolve that problem and address that problem? So that's for sure. It's going to be a big thing this year, and it goes so fast. God knows where we will be at the end of 2024 with this, but we will certainly have done quite a lot of things around that. And I would say, the other trend. It's not so much a trend, but it's coming a realization. And I think we still have a lot of people that do not realize this is a different space. It's not the traditional AppSec security. APIs are different. So there's still a lot of education to do around this, actually, to tell people and educate them around APIs are different, architectures are different. It's all about data. So that message still needs to get out, even in 2024. It's less than when we started 5 years ago, but still, there's still enough education to do. So I'm glad on that podcast to actually do that.
I think the integration here between the Defender and 42Crunch will actually make it visible for the SecOps team to understand the developer security, and that's a part missing. So it's make it possible for me as a non-developer to understand that we have something happening in the developer part of the APIs.
And close that loop as well, because so I've seen some problems and I bring them back into the developer so they can fix it.
Yeah. And I would know what to ask them to fix instead of we have alerts, you need to fix something. We can actually pinpoint the alerts, so it's easier to communicate.
This is red. Go fix.
Yeah.
Exactly. Or you just see like a million requests, right? And you're like, okay, where are these requests coming from? I mean, this is more. I think it's really good. The transparency that this tool 42Crunch it offers into the whole API security.
Great.
Awesome.
I'm glad you like it. Any further questions, let me know. Happy to help.
I think we're sort of creeping up on 50 minutes here, so I think we're going to call it a day. Thank you so much, Isabelle, for your insights and for your great demo and presentation and everything, and Marius for your demo as well. And cheerio.
Cheerio.
Take care. Thank you. Bye-bye, everyone.